Let's look at the question. K's largest element in an array. We are given an integer array num and an integer k. We should return the k's largest element in this array. And we should note it is the k's largest element in the sorted order, not the k's distinct element, and we must solve it in O of n time complexity. We initialize a heap, the smallest element first, and then we add all of the elements from the array into the heap one by one, which keeping the size of the heap always less than or equal to k. So that will result in a heap which containing k's largest element of the array. The head of this heap is the answer, which is the k's largest element of the array. We use priority queue, which is a minimal heap, to keep track of the k's largest element in the input array. First, we initialize the empty list heap to keep track of the k's largest element. Well, the smallest element is at the top of the heap. Next, we loop through each element in the input array nums, and for each element, we push it onto the heap. If the size of the heap exceeds k, we just remove the smallest element from the heap. So this can ensure that the heap always contains the k's largest element in the input array. And after we processing all of the elements in the input array, the top of the heap contains the k's largest element, since it is the smallest of the k's largest element. And finally, we just return the smallest element in the heap. The priority queue has a size of almost k, adding or removing an element by using heap push or heap pop operation, which takes O of log of k time for each. For each element in the input array, we perform n operations, so the total time complexity is O of n multiplied by log of k time. Well, n is the length of the input array nums, and k is the input parameters, and the space complexity is O of k space, since we only keep k element in the priority queue at any point in time. We're using the n largest function to find the k's largest element in the input array nums. So this function returns the k's largest element from the input array nums in descending order. The time complexity of this function is also n multiplied by log of k. Well, n is the length of the input array, and k is the number of the largest element to return. Internally, we build a minimal heap of size k. The space complexity is O of k space. We iterate over the input array and adding each element to the heap. If the size of the heap exceeds k, then we're removing the smallest element. And the -1 index notation selects the last element from the k's largest element, which is equivalent to the k's largest element in the input array.